Hello everyone, this is Himabindu from the Department of CSIT. Today in this video, I would like to explain about the construction of Moore machine and Mealy machine. So as we already discussed, what is meant by finite automata with output. Though here in the finite automata with output, without output, we have two or three many machines. So here in the without output, we already discussed NFA, DFA, epsilon, NFA. And with output, we discussed the Moore machine and Mealy machine. And what are the differences between the Moore machine and Mealy machine we discussed in the previous video. Today in this video, we would like to explain about the construction of Moore machine and Mealy machine with the examples. So here we already know that a finite automata, it is having with output and without output. Here the with output, it is having the two types of machine. One is the Moore machine and one is the Mealy machine. And about the without output finite automata, we discussed about the DFA, discriminate finite automata, and non-discriminate finite automata, and epsilon NFA. So here the without nothing symbol also it is reading in the NFA, non-discriminate finite automata. So here the finite automata with output we have to represent with the Moore machine and Mealy machine. So here two types of machines are there for the output with output in the finite automata. Let's move to the discussion of construction, how to construct a Mealy machine. Here we are taking the example, we have to construct a Mealy machine that produces one's complement as the output of the any given binary input string. So here we already know that in maths we have one's complement. So one's complement in the binary representation. So here here in this one, alpha is equal to 0, 1. These are the alphabets in the input symbols which are involved in the construction of finite automata. And here if you give any input string 0, 1, we have to write the one's complement for this one. In the sense we just replace 0 with 1 and 1 with 0. So what is the one's complement for this one? One's complement. So one's complement for this one is 0, 1. So here the one's complement is 1, 0. So instead of 0, we are replacing it with the 1, and here 1 instead of 1 we are replacing it with the 0. This is the one's complement of any input string. What we are taking here input symbols is 0, 1, that is a binary representation. Let's construct the Mealy machine for this one. So here what is our intention is the one's complement. So here the one's complement, so whatever the input symbol is there, that is replaced with the another input symbol. So if you replace 0, if you want to replace the 0, it will be replaced with the 1. If you want to replace one's complement of 1, we have to replace it with the 0. So let's construct a Mealy machine for this one. So as usual we have to start with one state, and it is the initiation. Arrow mark is the initiation, and here we'll take here we'll represent 0 with 1. So here we already know that the Mealy machine is having the dependent on present state. It is dependent on present state and input symbol. So here in the diagrammatic representation of Mealy machine, we have input as well as output. So if you give 0 as an input, it will give the output 1. And if you give 1 as an input, and it will give the output 0. So here it is the input and this is the output. Here it is the input and it is the output. So here it is the here it is the Mealy machine which was constructed for the one's complement of any binary number. So let's check for given one string. So here we have to one's complement for 0101. what is the output? This is the input string. So this is the input string. So if for this input string, we have to check for this Mealy machine whether the output is given or one's complement or not. We'll check it. So here 0, when we are giving the input symbol 0, so this is the output. So when we are giving the 0 as an input symbol, it is going to the self loop, its state A, and it is giving the output 1. So what is this? Is the output, and this is the state. So again, after reading the 0 symbol, we have to move to the 1 input symbol. So 1 input symbol for A, if you give 1 as an input symbol, it is moving to again A state and giving the output 0. And same thing, 0, if you give 0 to the state A, input symbol to the state A, it is having the output 1. And input reading this 1 for the state A, it is more giving input, taking the input symbol 1 and giving the output symbol 0. So this is the input string is output string. So here input string is 0101 and the output string 1010. So this is how we have to construct a Mealy machine for the ones complement of any given binary number. Let's move to the another example, the construction of Mealy machine. The construction of Mealy machine that prints A whenever the sequence 01 is encountered in any input binary string. So here is a constraint, like there is a rule, like if you encounter in a string, if you encounter 01 in an input string, it has to print A. So what is, let's elaborate this one. So if you take the input string 0110, so this is the input string. So this is the input string. So for this input string, when we occurred 01, it has to print A. So when we occurred input string 01, it has to print A. So this is the constraint. Let's construct a Mealy machine for this rules. And here, as usual, we have to draw the starting state of this one. So starting state is A. And let's first define the DFA for the construction of 01, sequence 01. And later, we will draw the Mealy machine for this one. And what is the DFA for the 01 sequence? So there is in input binary string. So there is a no constraint here. The starting symbol is this one and ending symbol is this one. So they are saying that the substring, like 01 is a substring in input string. If you encounter 01, it has to print A. It has to print the output A. So that is the only constraint they given. So here I am constructing a DFA for this 01, and so minimum length, as we already discussed, when construction of NFA or DFA, we have to find the length, minimum length. Here the min length of the string is 2. For this one, how many states we require for this one? In the sense 2 plus 1. So that is n. If it is n symbol, it is n plus 1 states are required here. So here this is the minimum length 01, it is a 2, and how many states we require for this one? In the sense 3 states. So we are taking the 3 states and we will minimize this DFA for this one. So let's encounter 01. So it has to print A. So let's draw this one. So when I encounter 01, it has to print A. So for this one, first analyze this input symbols. What are the input symbols here? What we have taken in the input binary string is 01. So what is there in the 01? And here what has to print in the output in the sense? So output should be capital O and it should be written in small a, b. We are taking these two outputs. Whenever 01 encounter, it has to display A, and remaining all, when our encounter single 0 or single 1 or it's a combination of except this 01, it has to print B. So like that we have to construct a DFA for this one. and next, and for the C, and here what we have to do, remaining all, we have to construct remaining. So whenever we already saw this input symbol 0, and what about remaining 1? So if I get an input symbol 1, what it has to display? And again here we already have 0 and 1. For the B also only one input symbol is there, and if you give 0 input symbol, it has to be self loop. So it can be repeated here from B also. If in the middle of 0, 1, if you get another 0, it will accept with 0, 1. So it will print A. And here we already have 0 and 1. And here from C, if you give 0 and 1 as an input symbol, where it is going from the state C. So if you give 0 from the state C, it will reach the B. And here if you give 1 as an input symbol, it will reach A. Why? Because if you encounter 0 here, it will like this. Here and here also, whatever we have, whatever 0 is there, if it will go to the B, and again it will 0, 1, it is repeating. And if you get the 1 as an input symbol from the state C, it will move to the state A, and again it is the starting 0, 1, it should be this will be satisfied. And here what is the main constraint? Here if you encounter 0, 1, then it should be print A. So what we have written, the remaining all the outputs here, it is A or B. So we already told that only for the sequence 0, 1, we will get the output A, and remaining all the possibilities of single A, a single 1, 0, or whatever it is, it's a combination of multiple inputs. So except this 0, 1, it has to print the B. So this is how we have constructed a Mealy mission for this one. Let's check, and we'll take one input string and we'll check for this whether we'll get the whether we will get the output string A as not. If we give input string 0, 1, 1, 0. So here we have taken the input string. So in this input string, what is the output string? What we will get whenever we encounter 0, 1, it has to give the A as the output. So let's check for the input string 0, 1. So what is the starting state here? Where we have to start with A state, and here the starting state, if you give 0 as an input symbol, it is going to the B. So here what is the output here for the 0? It is B. So for the 0 input symbol, what is the output here? B. And for it is going to the B state. Whenever giving the input symbol 0, it is going to the state B. And now from the B state, if you give 1 as an input, it will reach the C state. And what is the output here? A. And here is the output. And after this one, whenever we encounter from the state C 1 as an input symbol, it is having the B as an output symbol and it is reaching A. Again from state A, it is having 0 input symbol and it is getting output as a B. And what is the output string here? Or B, A, B, B. So here we got the A. So from this we can say that we have the sequence 0, 1 in our input string. Like this we have to construct a Mealy mission for this example. And let's move to the another example. Construct a Mealy mission for a language that accepts all strings over AB that ends with either AA or BB. So here OR symbol is there and we have two sequences. For example, we have seen only one sequence. So here we have to check for the two sequences. So what is the sequence? Here we have whenever we occurred in the input string AA or BB, it has to print 1. So it has to print 1. Remaining all, it has to print 0. So this is the elaboration of this Mealy mission. So for this one, what we have to do in the sense, as usual, we have to start with the starting state A. And for this one, input symbols, what are the input symbols here? 0, A comma B, and what is the output symbol? We are taking 1 comma 0, 0 0 comma 1. So let's start with the stat A. And here whenever we encounter, we have to check for the two sequences. One is AA and BB. So for this one, there is a OR symbol. From the state A, we have two input symbol. So we have taken A and we have to take B. And for this one, if we want to it has to be self loop. This is the construction of DFA. And next for this one also, whenever we encounter B, it has to be self loop. And whenever here we have the sequence AA and BB. For this one, what is the output here? 1 and 1. So here we will, if you check here A, how many times it is A? It is having the output 1, and here also B, and B next continuous B, it is having the output 1. So this is satisfied here. And what about the remaining inputs? So till now we have seen only two inputs for the state A, and for the B and C we have to check for the another states. So here another input symbols. If you already A is there, and for the B as an input, it is going to the C. And for here B already there, and whenever we give A as an input, it is going to the B state. This is the DFA construction for the either AA or BB. So let's analyze these outputs of sequence AA and BB. It's already done. So 1 1. So except these two sequences, the remaining all get 0. So that should be written like this. The output of remaining all input symbols is 0. So this is how we have constructed a Mealy machine for the strings ending with either AA or BB. So let's check with input string. So if you take AA and BAA. So for this input string, what we will get? Output string in the sense. So we have to draw the state A. So state A, it is moving to A input symbol, it is moving to B. And here from the B also it is having B. So what are the output here? A. What is the output? 0. And B as an input symbol, it is getting 1. And so from the B also, if you get, it is going to be from B as an input, and it is moving to the B as an input, it is reaching the state C, and with the input symbol 0, with the output symbol 0. And from the state A, state C, if you encounter A as an input symbol, it is going to B state. So it is going the B state, and with the output 0. And from the state B, if you give A as an input, it is reaching the self loop. So it is moving to B state, and it is having the input 1. So output string is 0 1 0 0 1. So here if you encounter 1 in output string, that says that there is a sequence of either AA or BB. So this is how we have to construct a Mealy machine for the either AA, or when you encounter AA or BB in the Mealy machine. And let's construct a Murray machine for this one. Murray machine. So what is meant by Murray machine? So we already discussed the Murray machine and Mealy machine. What are the differences between the Mealy machine and Murray machine? Here the Murray machine is having the difference between the Mealy machine and Murray machine is Murray machine is dependent on state, and it is also having the output as well as in the state itself. So here like this we have to construct a Murray machine for this one. What is the example here what we have taken? So binary string as an input and prints A as an output whenever the sequence 01 is encountered. So this example we have already discussed in the Mealy machine. We already discussed this sequence. When you encountered sequence 01, it has to write the print A. So what is the input symbol here? 0, 1. And what is the output symbol? So here the output symbol is A. Whenever we encounter 0, 1, it has to print A. So remaining all, it has to print B. So B. we are taking the two input and output symbols. So let's draw the Mealy machine, and as usual we have to construct a machine. Starting state is A I am taking, and whenever we encounter 0 1, it has to print 0 1. So as usual minimum length is n. So here n is 2 and 2 plus 1, 3 states are required here. So here, and what is the output? So whenever we encounter 0 1, it has to print A. So remaining all, it has to print B. And as usual, we have how to construct a DFA. We have already encountered a 0 input symbol. If we encounter 1 as an input symbol, it is going to a same state. And whenever we encounter 0 input symbol for the state, 0 input symbol for the state B, it is going to the same state itself. And here the state from state A, so is state C, if you encounter 0 input symbol, it is going to B state. And whenever we encounter 1 as an input symbol, it is going to A state. So Mealy machine is having like this. So here the B. So the output is, here we are representing in the state itself, but here we are representing it with the out of the state. So transition, in the transition we are displaying the output, but in this Mealy machine we are displaying in the state itself. That is the difference. And next we'll construct a Mealy machine and counts another example that counts the occurrences of the sequence AAB if in any input string over A comma B. So here the input string is having 2 alphabets, and output string, it is our opinion to will take 0 or 1. So whenever we encounter A, B, B, it has to print 0. And remaining all, it has to print 1. So for this one, how to construct a Mealy machine? So we already discussed the Mealy machine, it is having, the state itself is having the output. So let's draw this sequence first to construct a DFA for this one. So let's start with A input symbol, the A state, and B and C. And here the minimum length is 3. So plus states are required. So 4 states are required here. So D. So here what is the sequence? A, B, B. So whenever it is reaching this final state B, B, it has to print 0. So this is the output here. It has to print 0. Remaining all are 1, 1, 1. So what is the, let's construct a DFA, the remaining input symbols. So it's already B, A is there. How to construct B? If you give B as an input symbol, it is reaching self state. And here B is there. And how to construct A? If you give A as an input, it is going to the self loop. And here, if you encounter C, if you encounter A as an input symbol, it has to go to the B state. Why? Because the loop is repeated, like the input string A, B, B is satisfied here. A, B, B is satisfied here. So and here we already A is input there and B input there. And here for the from D state, so if you give A as an input, it has to again go to B state. Why? Because the repetition of A, B, B is possible. And here, and if you give 1 as an input symbol, B as an input symbol, it has to go to A state. Why? Because if you give encounter in the middle of B, so it will again the same sequence is going to be after B, the same state is going to be repeated. Like this we have to construct a DFA for this one, as well as if you give as an output from the state for the states, it will be converted to a Mealy machine. So let's check one input. We'll take one input string. When we encounter A, B, B, so A, B, 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 I am taking triple B, how it is going. the state A we have to start, and for the state A, what is the output here? 1. And from state A, if you give A as an input, it is going to B. So B, from B state, it is 1, and it is going to B as an input. So it is going to C state, and what is the output here? 1 as an output from first C. And for C also, from C also, it is going to input from C. If you give B as an input, it is going to D. So D. So what is the output here? 0. So here what we get? 1, 1, and again. So from D, if you give B as an input, it is going to A. And what is the output here? So what is the input string? Input string is A, B, B. And what is the output string? 1, 1, 1, 0, 1. So here we already discussed the Moore mission. So minimum the input string length plus 1 we will get in the output string. So what we got here, the 4 length is there, but here we got 5 length in the Moore mission. And if you observe, if we encountered 0. So here that is the meaning, if there is a sequence of A, B, B in the input string. If we see this output 0, it is having 0. So here we encountered A, B, B in the input string. So like this we have to construct a Moore mission, and these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.